Yeah, to finish up with this little series, I wanted to use the AOV function. Now that's Anova, analysis of variance, which is often used in conjunction with the LM function. So I'll call this something completely different. Help, since people need help in this kind of situation. Now, AOV. AOV is analysis of variance. You do not need a package for this, but it's pretty good. So we're going to just use the same exact um uh argument here. We're just going to lay it out the same. So you basically have, what's the dependent independent variable again? Death estimates, dependent variable. And then you have conflict type, where we got it. And then we definitely want to write data in these cases because you don't want to get confused. Okay, now you can call these anything you want. Summary. You also do summary AOV. We could actually put the lamentable deaths in the other summary. I'll explain that because sometimes people ask these questions. Now, this is the sum of square mean square. So you're dealing with a different algorithm, which we're not going to get into. But the point is, oh, wow, these are at the E level scientific notation. You've got to see degrees of freedom, the number of cases minus the independent dependent variable. The sum of squares are interesting, means for right now, the bigger here, the better for these two, and the F value, that's a high F value, so you see it's really statistic. And down here, residuals, the smaller the better. Now, those two, not the degrees of freedom. So why? Residuals are, we want, well, I don't know if we should say we want, but your model is better if it can predict as much as possible. Residuals is the lack of prediction, for lack of a better word, what you're not predicting in these models. Not a particular variable, but the extent to which there is variance in your predictors. So here we're seeing if conflict type predicts the death estimates with the AOV function, the analysis of variance. It's pretty cool. And the F value is like a global value of these internal, internationalized, etc. conflicts. And it's coming up similar to the LM function, right? Very significant here. But what's interesting with this is, and I want to stress this, is that you have another test you can do to compare each type, and this might make it, for the lack of a better word again, more amenable to understand the comparisons. So it's just a Tukey test. There's actually two, because I downloaded an RS Stacks, but I'll stay with the Tukey test. I call it Turkey LSD, Crazy Turkey LSD, but it's really Tukey HSD, named after Tukey, where it's a post-hoc test of comparison. So I called this one help, right? Look at it, help. It's got the stars, the party, etc. Now, this is all we're going to really focus on is here, but you're seeing the comparison, internal versus interstate, right? So you see those two comparisons, that's significant. Then internationalized versus interstate, right? You're seeing that is significant. And then internationalized versus internal. Since you have three different variables or attributes of this variable, variable is conflict type. The attributes are internal, internationalized, and interstate. You see here, right, that they're all compared. And what we're looking at here is the p-value, which all are under 0.05, which means we can say with strong confidence that the type of conflict correlates significantly with the amount of death estimate. So the estimates of death, I'm just reading it here, but like, you know, the estimates of the deaths that were coded. So the type of conflict does matter in these cases. There's also other, if you could see, I did it, another test which was the Bonferroni, which is a little more conservative. Here, I'll just put it up here. It's the pairwise t-test. So again, conflict, but this is a different format to put it in. This is called a pairwise, because these are all pairwise because we're pairing each of the attributes to each other with under the variable conflict. So here, pairwise t-test is conflict. Then as you remember, here, I'll just do it here again so you remember conflict 2, just here. Conflict 2, then all you got to do is hit the dollar sign, keeping the dollar afloat. Conflict type, all right. Oh, no, I was incorrect. Because in this case, it's the same thing as the other cases. The dependent variable has to come first, so it's death estimate. And then conflict 2, conflict type. But this is this is the Bonferroni test, adjust, right? Let's take a look. And these are still very significant, as you can see. That's a more quote unquote conservative test. When I say anytime conservative, I'm not talking politically. I'm talking about it's tougher to get a p-value of 0.05. But that's the Bonferroni test. That's another person who helped kind of building off Tukey, or maybe Tukey built off Bonferroni. I don't know who came first, the turkey or the Bonferroni. But the point is that there's different types of post-hoc tests. Some are more difficult than others. So the Bonferroni is known for being quite a conservative test, a little tougher to get. But as you notice, it didn't matter here. These are very significant, very significant attributes in the variable. So the type of test, they come out differently, obviously. The type of conflict does determine the amount of battle deaths. So that was, again, to recap, this is the AOV function, analysis of variance. It's AOV, there are different Anovas with different packages, but now we're just focusing on Anova, the default. This is to see if conflict type, again, leads to more deaths, data conflict 2. In this case, we're seeing a very strong global significance here. The F value, higher, better, like the T or the Z value in LM function. Come down here. Now we're going to do a post-hoc test, right? Compare these two, and they're all significant. And you go down here, they're even more, well, even look at that. Very significant. So, this is very, very important to understand. This is what real practitioners and academics alike do in order to understand conflict from the focus of quantitative big data machine learning stuff. Now, remember, this might not be battle deaths. This could be a lot of things, like the type of right here, you could have COVID policy, type of deaths. I mean, you could do a lot more things with this. It's not just about conflict, but this is what we're using here. So I hope you enjoyed it. Take care, everyone.